In this video, we are going to take a discrete time system and we'll check for the properties. So the equation is given by y of n equals x of n plus n times x of n plus 1. So this is a system for which we need to check whether it requires memory or not. That means whether it's a memoryless or not, that we have to check. Then we'll check for the causality, linearity, and in the end, time invariance. So let's solve one by one. So y of n is x of n plus n into x of n plus 1. So over here, it is but obvious that suppose in the expression y of n, I need to get the value at an instant n equal to 1. So y of 1 is x of 1 plus 1 into x of 2. So basically, if I see x of 1 is nothing but a present input and x of 2 is the future input. So what I can say, output of y of n, which I say a present output of y of n depends on present and future, and sometimes depending upon what is the value of n, whether it is a negative. So what I can say, present output of y of n depends on present and future inputs. So system requires memory, hence it is not a memoryless system. So to store a future input value, system requires memory, hence system y of n is not a memoryless. So first conclusion we have drawn. Next is for the causality. So from one I can say, since the present output depends on future input, I can say system is not causal. Let's find out for the linearity. System equation is y of n equals x of n plus n times x of n plus 1. To check the linearity, we are going to apply two inputs. So let x1 is applied to the system to produce y1, and y1 is nothing but, so what is happening inside a system? Signal as it is plus shifted version of input multiplied by n. So this is the first equation I obtained. For the second input, output is y2n, and y2n is also given by signal as it is plus n is getting multiplied with a shifted version of the signal. Now let's apply a third input, which is a linear combination of x1 and x2. Third input will give a corresponding output y3n. And what is happening inside the system? The signal as it is plus n is getting multiplied to the shifted version of the signal like this. So y3n I obtain, see x3n as it is, that means it is a times x1n plus b times x2n, that need to be added with n times shifted version of this. So it is a times x1 n plus 1 plus b times x2 n plus 1. So if I simplify, I will get y3n as a times x1n plus n into 8 times x1n plus 1 plus b times x2n plus n into b times x2n plus 1. Now just taking a and b common from these two expressions, I will get y3n as a bracket x1n plus n x1 n plus 1 plus b x2n plus n times x2 n plus 1. So if you observe, y1 and y2 from the equation 1 and 2, I can say at the output side we are getting those outputs y1 and y2. So from 1 and 2 we can say y3n is a times y1n plus b times y2n. So pertaining to this expression, I can say system is linear. So linearity is satisfied over here because this system exhibits the property of homogeneity and superposition. Let's check for the time invariance. So system is phi of n equals x of n plus n times x of n plus 1. Our input is applied to the system, which is x1n, and corresponding output is y1n, which is nothing but a signal as it is plus n is multiplied with a time shifted version of x1, equation number 1. Second signal is x2n, which is nothing but a time shifted version of the original signal, which if I apply to the system will give y2n, and this y2n output of the system is nothing but signal as it is plus n times time shifted version. Now x2 is already time shifted version of x1, so if I substitute, I will get y2n as x1n minus k plus n times x1 n minus k plus 1, equation number 2. To check the time invariance property of a system, we need to replace n by n minus k in equation 1, which is y1 n minus k equals x1 n minus k plus n minus k x1 n minus k plus 1, equation number 3. Now if you closely observe equation number 2 and equation number 3, I can say these two equations are not equal because of this extra term. So in the end, from 2 and 3, I can say y1n minus k not equal to y2n. That means if I shift the input signal, I am not getting corresponding shift at the output side. So pertaining to this, I can say system is not time invariant. So system Y of n is not a time invariant. So let's write a summary. So given system, which is Y of n equal to x of n plus n times x of n plus 1 is not a memoryless, not a causal, but it is a linear and it is not time invariant. Here is the end of our problem. Thank you.